Hi students, in today's class we are going to see about the relational data model. In relational data model, we are going to store the data in a structured form in tables. By using this model, we can easily store and retrieve the data, and also we can check for duplication and redundancy. Redundancy means multiple occurrence of the same data, and we can ensure the data is protected from unauthorized access. So, the objective of today's class is that at the end of the session, you will be able to understand what is the structure of relational database and how the data can be manipulated using relational algebra operations. So, let us start the session. Before starting, we shall have a small recap. We know data models. Data models are classified into 6 types. They are ER model, relational model, object-oriented model, semi-structured model, network model, and hierarchical model. You are familiar with the ER model, that is, the data are represented in terms of entities, attributes, and relationship. Now, our focus is on relational model. There are many famous relational databases like MySQL, Oracle, Microsoft SQL Server, IBM Database 2, Sybase, etc. In a relational database, data are stored in tables which are related by means of a common field. A table can also be called as a relation. So, consider a data set. So, a data set is stored in a table with multiple rows and columns. So, consider this example. This example, it consists of information related to a student with attributes like roll number, name and age. And consider another example. This table consists of information like customer ID, name and order. So, it is a customer table. In a table, each row is called as a record or a tuple. So, a record or a tuple, it consists of one complete unit of information about the person. Similarly, in a table, each column is called as field or attribute. So, the field or attribute, it contains the information about the type. So, roll number is one type, name is one type and age is another type. In a table, the number of columns is called as the degree of a table or relation. So, in this example, the degree is 3 as there are 3 columns. And in a table, the number of rows is called as cardinality. In this example, the cardinality is 4. Let us quickly look into some questions for a better understanding of what is degree and cardinality. So, in the given example, in the given table, what is the degree and cardinality? The degree is 4 and the cardinality is 5 because there are 4 columns and 5 rows. Another example, in this example, what is the degree and cardinality? The degree is 2 and the cardinality is 5 because there are 2 columns and 5 rows. Hope you understood. Next, an important aspect of a table is that each entry of a table should contain unique values. Let us consider an example. In this example, you can see there are 2 entries of similar values. Suppose, if I want to update the marks, in which row shall I update? These can be handled by the concept called keys. So, in a table, at least one attribute or one column should be able to uniquely identify the relation, and such attribute is called the primary key. And in a table, there can be more than one column or attributes that uniquely identifies the relation. Such attributes are called candidate keys because they are chosen to be candidate for a primary key. In such case, one attribute is taken as a primary key and another attribute is taken as an alternate key. There is also a situation where you can combine two attributes and that composition can be used for finding the uniqueness of a relation, and such key is called composite keys. Now, in a database, there are multiple tables which are linked together. In such cases, we use the concept called foreign key. Consider the example. There is a table called student and another table called result. Now, in student table, we have an attribute called roll number, and in result table, we have another attribute, the same attribute name called roll number. These two are linked with each other. Now, the roll number attribute in the result table is called foreign key and the roll number attribute in the student table is called primary key, because the result table, it is referring the student table, that is referring the primary key in the student table. And here, next concept is referential integrity constraint. That is, whenever we are working with the foreign key concept, there will be some constraints imposed on the foreign key in order to prevent the entry of wrong information, because for each entry of the primary key, there should be an equivalent value in the foreign key. For example, consider the situation here. Now, there are 5 entries in the primary key of the parent table, and here there is corresponding entries in the foreign key as well. But in the next situation, a key has been entered with the number 26. For 26, there is no reference in the primary key table. So, this is violating the rule, or here wrong information has been updated. So, in order to prevent this, we are going for the referential integrity constraints. Integrity means ensuring accuracy and consistency of data in the tables. Next is schema diagram. So, schema is nothing but it is called a structure. So, schema diagram means it is a pictorial representation of the database schema, and here it displays the primary key and the foreign key dependencies as well. Let us see the diagram of a university database. So, here you can see there are multiple tables which are interconnected with each other. Now, let us start with the department table. In the department table, you have multiple attributes like department name, building and budget, and this department name has been underlined, which means department name is a primary key for the relation department, and this department, it is associated with table called student, course and instructor. You can see in student also there are multiple attributes. In course table also there are multiple attributes. Likewise, in instructor table also there are multiple attributes. Now, in student table, student ID is taken as the primary key, name, department name and total credits are other attributes. You can see the department name attribute in student relation as well. Now, this department name, it acts as a foreign key in student and primary key in the department relation. Similarly, in course also you can find the department name attribute. So, here department name is the foreign key in the course table, whereas department name is the primary key in the department table. Similar with the case of instructor. And here if you take this instructor, instructor means a faculty, maybe a faculty. So, their role is to teach or to guide the student as an advisor. So, likewise, other tables also interconnected by means of a common field called keys. So, that's all about the structure of relational database. So, let me give a small summary. Let me summarize. So we have seen about what is a relational model. So relational model, it is a structural model where the data are stored in a proper structure called tables, and here table is also called as a relation. In a table, each row is called as a record or a tuple, and each column is called as an attribute or fields. So in order to ensure uniqueness of table entries, we are going for the key concept. Primary key, there will be only one attribute in a table which uniquely represents the record. So that attribute is called primary key. And there can be more than one attributes that uniquely identify the record. Such attributes are called candidate keys. And among the candidate key, one key will be considered as a primary key and the remaining are considered as an alternate key. And there is some situation where a combination of two attributes will be considered to find the uniqueness of the table. Such key is called composite key. In foreign key, when tables are interconnected with each other, so the foreign key concept can be used. That is, primary key which is used in a child table, or when it is referred from the other table, that key is called as the foreign key. And foreign key, we are using referential integrity constraint, which means some conditions are imposed on the reference, that is foreign key, in order to prevent the entry of wrong information. And at last we have seen about the schema diagram. So hope you got a better understanding of what is a relational database model. Yes, now we shall go to the next topic called formal query language. In that we are going to focus on relational algebra. So what is a query? A query means it's retrieval of information, and query language means the language which is used for retrieving the information. So formal query language act as a source from which the structured query language are developed. There are two types. One is relational algebra, other one is relational calculus, and that relational calculus are further classified into tuple relational calculus and domain relational calculus. So relational algebra is a procedural oriented language, whereas relational calculus is non-procedural oriented language. That is, it just tells the system what data to retrieve, but it does not say how to retrieve it. And in that, tuple relational calculus means it will help to select a particular record based on a condition, whereas in domain relational calculus, the records are selected based on the domain. But here we are focusing only on the relational algebra. So relational algebra, it is a procedural query language where it takes a set of operations it consists of set of operations that take one or two relation as input and produce a new single relation as output. The fundamental operations of relational algebra are select, project, union, set difference, Cartesian product, rename. Among these operations, select, project and rename are unary operators, whereas the remaining thing, union, set difference and Cartesian product are binary operators. The select operation. So the select, it is used for selecting a tuple or a record based on a given condition, and it is denoted by the lowercase Greek symbol sigma. It is used for producing horizontal subset. For example, consider the student table. So the student table, it consists of three attributes: student ID, name and address. And here the syntax of the select operation is sigma C of R, where C is the specific condition we are applying on the tuple. R is the name of the relation. Now my query is to find all the students whose ID is above 300. So the query comes like this: sigma student ID greater than 300 from the relation student. Upon executing this query, you will get the result like this. So from the table, I want to select the tuples which satisfies the condition where student ID is greater than 300. So let us take this table. The first entry, the student ID is 123, which is not satisfying the condition. So this will not be displayed. Whereas the second entry, if you check, it is 345. So 345 is obviously greater than 300. So this particular row is displayed here. And next one, 567, yes, it is also greater than 300, so it will be displayed here. So this is how this select operation works. Next one is project. The project operation, it selects an attribute based on a given condition. It is denoted by a lowercase Greek symbol called pi, and it produces vertical subset. It is used for eliminating the duplicate values. The syntax is pi a of r, where a is the set of attributes. So here I want to display all the student IDs from the given table. So my query is pi student ID from the table enrollment. On executing this query, I will get the output like this. So only the student ID attribute will be completely displayed. This is about the project operation. So here you can see, as I have told, select means it will produce horizontal subset, whereas project means it will produce vertical subset. Now for a better understanding, I have given you one table example from where we can see how the select and project works. So consider a table called person with 4 attributes: ID, name, address and hobby. Now my select operation is, I want to select the records where my hobby matches stamps. So the query is sigma hobby equal to stamps from person. On executing this query, my output is, so here 2 entries only matches my given query. Say John with the ID 1123 and Bart with the ID 9876 only matches this query. So my output table consists like this. Now I want my project function to display 2 attributes called name and hobby from person. So I have given the query pi name comma hobby from the person. On executing this query, I am getting a table like this, displaying the 2 attributes. Next operation is union operation. So in union operation, it will create a relation as an output which contains all the values of both the relations which are taken as input. And union operation helps to eliminate the duplicate entries. It is denoted by the symbol U. Now, when 2 relations are involved in union operation, they are said to be union compatible only if both the relations have same number of attributes and their attribute names are same. Take for example, there are 2 tables, S1 and S2. So S1 table contains 3 records and S2 table contains 4 records. Now I am applying the union operation here. So just see, first entry is from S1, student ID 22, student name Dustin, rating 7, age 45. So it will check for any duplication in the second table. Is there any value similar to this in the second table? No. So that value will be taken and displayed in the output table. See, 22, Dustin, 7 and 45. Now consider the second case. 31 is the student ID, student name Labba, rating is 8 and age is 55.5. Could you able to see any record which is similar to this in the second table? Yes. The second entry of the second table matches with the second entry of the first table. So, in order to avoid the duplication, only one entry will be updated in the resultant table. Next, the third entry. So, 58, Rusty, 10, 35. So, let us check for any duplication in the second table. Is there any data matching here? Yes, the fourth entry, it is matching with the third entry of the student table. So, there is duplication, so it will avoid the redundancy and display only one entry in the resultant table. Next, come to the second table. Here, the first entry is 28. This is the student ID and student name is Yuppie, rating is 9. Now, it will check for any similarity in the first table. No, there is no such data in the first table, so it will directly make an entry in the resultant table. And second case is 44 is the student ID, Guppy is the student name and rating is 5. Here also no such similar data is found in the student 1, so it will directly take and display it in the resultant table. So this is how a union operation works. Next is the set difference operation. So the set difference operation, it allows to find the tuples which are in one relation but not in other relation. It is denoted by the symbol minus. Now let us understand this concept with an example. Again, there are two tables S1 and S2. So the fact is that we should contain the data in only one table and that data should not be present in the other table. So consider student 1, the first entry is student ID, student name is Dustin, rating is 7, age is 45. So let us check whether the data is available in the second table. So Yuppie, Lubber, Guppy, Rusty, no, the Dustin is not available. So we will take it and display it in the resultant table. Now check for the second entry. The student ID is 31, student name is Lubber and rating is 8. Yes, so this data, it is matched with the second data of the student 2. So there is duplication. So the fact is that the data in one table should not be present in the other table. If it is present, we will just eliminate the data and we will not display it in the resultant table. So, as a result, the resultant table, it contains only one entry in this case. So, this is about the set difference operation. Next one is Cartesian product. So, in the Cartesian product, the resultant table combines each row in one table with each row in other table. So, just like a multiplication, how we are performing with the numerical matrices. The same happens in the Cartesian product. So, you can see 22, Dustin, 7, 45. This entry is added with the first entry and displayed here. Again, the first entry of student 1 is entered with the second entry of student 2. Likewise, each entry of student 1 is copied with the each entry of R1, and the resultant table, you can see there are so many duplications and redundant entries occurring here. So, Cartesian product is mostly not preferable. The next concept is rename. Next operation is rename. So, normally we won't name the resultant table, but if we want to make use of the resultant table in the future, it is good to rename the table. So, for renaming that relation, we are going for the symbol called row. So, the syntax is row x of e, where x is the new name for the relational algebra expression and e is the expression that we are working with. So, we have seen about the fundamental operations. Now, we are going to see about the additional operations in the relational algebra. The additional operations include set intersection, natural join, outer joins. Under outer joins, we have left outer join, right outer join, full outer join, and finally assignment operations. Let us see one by one. In set intersection, as the name implies, intersection, we are going to focus on the entries which are common to both the tables. So here there are two tables, one is graduates, another one is managers. So what we are going to look for the entries which are matching with each other, and I am going to display those matching entry in my resultant table. So this is how the set intersection works. So in this picture you can see A is one relation, B is another relation. So when I put it in a set operation, the intersection, the common part only is the thing which we are in needed. The similar thing happens over here. So here you can see the second entry and the third entry matches with the second entry and the third entry of the second table, and that is displayed in the resultant table. So this is about the set intersection operation. Next one is natural join. So in natural join is also combining the entries of two tables, but here for combining the tables we should contain at least two attributes similar in both the table. Then only we can able to perform natural join. Say, consider an example where this is one table called R and this is another table called S. So in table R we have two attributes called B and C, which is matching with the same attribute name B and C with the table S. See, BC, here also BC, BC, here also BC, and AD, here also AD. So we are just going to combine the entries that are matching alone. So the resultant table you can see A, B, C, D, A, B, C, E, and D, B, C, D, D, B, C, E, finally C, A, D, B. So this is how the natural join works. So it will avoid duplications. Now left outer join. So here also we are going to perform a join operation of two relations, and as the name implies, left outer join means it will include all the entries of the left table and it will just display the values of the right table which is matching with the entries of the left table. Suppose if there is no data in the right table, it will just include the null values in the table. So you can see in the left table you have three entries with 100, 101 and 102. In the right table you have three entries 100, 102 and 104. Since we are performing the left outer join, our resultant table looks like this. So 100, 101, 102 will be displayed, and for 100 the matching entry of the second table is displayed, 100 Alex. Similarly 101, there is no entry in the second table, so it will simply display as a null value. Whereas in third entry 102, the left table entry is here and the matching right table entry is 102 Maya. So this is how the left outer join works. Coming to the right outer join, it is just opposite to the left outer join, where we will include all the entries of the right table and display the corresponding left entries. Say 100, 102, 104 are displayed here. Now let us see, for the 100 first table there is a matching entry with values 100 and database, and for 102 also there is a matching table 102 electronics, whereas for 104 there is no matching entries in the left table, so I am simply putting a null value over here. So this is how the right outer join works. Next is the full outer join. In full outer join, all the entries of both left and as well as the right table will be included. See 100, 101, 102 and similarly 100, 102 and 104, all the entries of both the tables are here. So this is how full outer join works. The next operator is assignment operator. So like how we are using assignment operator in a programming language, similarly we will use assignment operator in relational algebra also. See the example R1, that is S1 and S2 are assigned, the Cartesian product of S1 and S2 are assigned to a temporary relational variable. So here S1 and S2 are two separate relations, we are performing Cartesian product and the resultant of the Cartesian product is assigned to a variable. So, same like a assignment operator, we are using the assignment operation here. Next is the aggregate function. Aggregate function are nothing but they are set of operations which are performed on a set of values which produces a single result. For example, take a table with a set of values. So, what operations we can perform? We can perform operations like sum, calculating sum, finding minimum value, finding maximum value, and finding the average. So, all these are the operations that we can perform with the aggregate function, and here aggregate function are denoted by using the symbol calligraphic G. Examples are sum, minimum, maximum, average, and count. So, here is an example for the aggregate function. There is a table called employee or relation called employee with 4 attributes: name, office, department, and salary. Now, I want to find the person with the minimum salary. So, I am just applying the query minimum salary of employee with the aggregate function. So, it will return me the output with 35,000 is the minimum salary. So, these are all the functions or operations of relational algebra. So, hope you got a better understanding of what is relational algebra and how the operations are performed. Now, let us look at the mind map. So, it gives even more a better understanding of what we have seen till now. So, the core concept is formal relational query languages, which means the relational algebra which we have focused. So, relational algebra we have defined, it is a procedural query language and it takes relation as input and produce one relation as an output. After that, we have seen what are all the fundamental operations: select, project, union, Cartesian product, rename, and set difference. Finally, we have seen some additional relational algebra operations like set intersection, natural join, outer join. Under outer join, we have seen left outer join, right outer join, and full outer join. At last, we have seen the assignment operation also. Then we have seen the extended relational algebra operations like aggregate functions. So, to summarize, we have seen about relational algebra, fundamental operations, additional relational algebra operations, and extended relational algebra operations. So, that's all for today's class. Thank you.